Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by students, faculty, and friends, and of course alumni, sorry, of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and tonight I'm joined by a special new host, Maheen Hamani, and we'll introduce her just after this introduction. Actually getting started here, we are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe Radio broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT, if that's more your speed. The York Universe production works in concert with our online public viewing program. That's right, that's what's on YouTube right now, online public viewing, or OPV. Runs exactly at the same time, 9 to 10 p.m. local Toronto time. And if you want to find out more about OPV or, of course, our wonderful episode archive, you can always check out our website, yorku.ca/science/observatory. You can follow those links down to OPV or click on any of our YouTube links to get to the main channel, where, of course, all the video recordings, not just audio, will live. If you have any questions or comments about past shows, suggestions for future topics, or interesting news stories that you think we should cover, please send us an email at observe@yorku.ca. You can always connect with us on Instagram at Yorku Observatory and Facebook at Allan I. Carswell Obs. And of course, all of our programs, including this one, are free. But if you'd like to make a donation, you can see that same website, yorku.ca/science/observatory, and just scroll on down to donations. All right. Our crew at OPV is monitoring the YouTube chat room for any kinds of questions or comments and posting content about our wonderful images. The current weather is a bit hazy, of course, and we do have, as advertised, a entirely new host for York Universe. So a big, huge welcome, I suppose, um, over to our newest host, Maheen Hemani. Maheen has been a steadfast staple of the observatory for ages now. I feel like she's been here longer than I have. But she is a BSc Honors Astrophysics student at York University going into her final year, and she's been part of the team since 2021. She's been doing research, all kinds of wonderful things, which maybe we'll talk about, peculiar quasars, high redshift galaxies, and she's still just doing undergrad. And of course, she's been at the observatory doing all kinds of things, including OPVs and teletubes and outreach and observing. So it's great to have her finally on York Universe as well. Welcome to the show, Maheen.
Well, thank you for having me. Hi, everyone. I'm sure you might have heard my voice in one of our Teletube episodes. It's great to be here tonight. Hopefully, you're all having a great day. All I want to say is stay tuned since we have a great lineup of space news and space history items today. So really looking forward to talking about some of these great things.
Yes, absolutely, and it's great to have you on as our official York Universe host now. And we are keeping a little bit of an eye out, just so our listeners know. We are keeping half an eye towards the weather, just in case it does clear. We have a crew standing by at the 1 meter telescope on campus, so we are truly live today. And if it is going to clear or get clear enough that there's no haze, we will be able to share live images in addition to the beautiful archival images that you're probably looking at right now over on our wonderful YouTube channel. All right. So getting started here, we've got, as Maheen said, lots of things to talk about. It just seems like there's always so much going on. So I thought I would start us off. Going back in history a little bit, there's been a lot of interesting things in the news, but we're going to go back to old-fashioned news. This week in space and astronomy history, 1986. Back in 1986, there were no there were cell phones, but they were big. Um, there were no flip phones. June 17th to around the 19th, and I have actually a conflicting date for this. It's either the 17th or the 19th. 1986, there was this is an interesting this week in space and astronomy history. This is the history of a paper publication. And the reason I chose this one is probably because it's a little bit relevant now. The paper was published in 1986, and the title of the paper is Orbital Debris Technical Issues. This is pretty interesting. This is all the way back in 1986. Orbital debris technical issues. Now, this paper was published by Donald J. Kessler of the Kessler syndrome or the Kessler effect. And this paper was all about uh, the problem of satellites, really, and the problem of space debris. Now, back in 1986, there were nowhere near the number of satellites that we have now, but it was understood that collisions in space could cause fragmentation. And of course, the more fragments of material you have in orbit, the bigger the chance of collision. And it only takes a little tiny, tiny, tiny little speck of metal going at a very high velocity to punch a hole in something pressurized like, oh, an international space station or something like that. So there's actually a famous syndrome related with this. So the Kessler syndrome or the Kessler effect is a collisional cascade where one collision leads to another collision, leads to another collision, and pretty soon your low Earth orbit has so many particles in it, it's just collisions all the way down. So this is pretty interesting. So this was all the way back in 1986 that this particular paper came out, and I would encourage our sort of space aficionados and folks who love history, check it out. Orbital debris technical issues, and this was, if you're really interested in finding it, it's the SDIO IST Second Pathways to Space Experimentation Workshop. So it was published there, and the full text is online. Um, so the Kessler effect or the Kessler syndrome came about as a series of publications and talks led by, of course, Donald Kessler, who wrote this paper. And he was a NASA scientist. And before he published this paper, about 8 years or so before, he was already proposing dangerous scenarios in which the density of objects in low Earth orbit would become so high that you would not be able to avoid collisions. And low Earth orbit, or LEO, space pollution is now an even bigger problem. So if you have collisions that cause a cascade, every collision generates space debris, which is going to increase the likelihood of further collisions. And we have actually seen since then, so over the last 40 years, increased collisions, increased space debris. So in 2009, Kessler continued advocating. So he's been, of course, looking at this since 1978. He wrote that the modeling results had already shown in 2009 that the debris environment, all the debris up there, was unstable. And any attempt to achieve a growth-free, and this is a quote, a growth-free small debris environment by eliminating sources of past debris would fail because fragments from future collisions would be generated faster than atmospheric drag could remove them. Because of course you think, oh, it's in orbit, it's in low Earth orbit. Well, then I guess we can wait until it falls into the atmosphere and burns up. But sometimes they're too big, and if your collisions are constantly generating more debris, then the generation of debris gets higher than they can be dragged down to Earth by the atmosphere, anyways. So, an implication of this, of course, is that if it gets to the point where you can't launch anymore, you could actually completely stop or prevent space activities. The distribution of debris in orbit could stop the use of satellites in a certain orbital range, and it could actually stop it for several generations. Around the year 2000, so by the year 2000, we had about 6,000 satellites up there. And this is, a lot. This is many more than they had in 1978 and 1986 when they were first pointing this out. Now we have just SpaceX itself with over 6,000 and planning to launch tens of thousands more. And there's over 30,000 total bits of collision up there. So I thought this would be a great time to remember the 1986 paper that came out by Donald Kessler of the Kessler effect, warning us about space debris and, of course, our low Earth orbit. So a little bit of history, and it's something to think about for sure today.
This reminds me of how disastrous it would be if we had a hole in the International Space Station. Like, I was thinking about what would happen if that were to happen, actually.
Yeah, and that's a real danger. It's you know, if it does depressurize, um, the astronauts would be, severely inconvenienced, and the best case scenario. And of course, with recent debris collision, it was 2022, I think, and I'll leave it to our listeners to fact check me on the exact date. But it wasn't that long ago that China decided to blow up one of its satellites to get rid of it. I think it was 2022 or 2023, created a massive debris cloud, and the astronauts in the ISS had to scramble for safety, and they actually had an emergency maneuver to try to get out of the way of this massive debris cloud. So if you've ever wondered why you don't want to blow up things to get them out of orbit, it's because it creates a massive debris cloud. They do actually have a special area of the ISS that is sheltered, but you're right, it would be an absolute disaster if it did get fully punctured. And it's not something that would be at all easy to replace. It's The space station has been under construction for decades. So you're absolutely right. And of course now we've also seen space debris come back down to Earth, which we'll talk about later in one of our news stories.
So I
Um,
guess it would be a great project for our student listeners to work on solving the Kessler syndrome problem. Um,
Yes, absolutely. Could you solve the Kessler effect or the Kessler syndrome? That would be a great way. And that there are people who have proposed various things. I will just give a shout out to all the folks who want to use lasers to push pieces of debris out of the way. It's a serious proposal, but it's a serious problem. So, yeah, go to town, students. All right, excellent. So we have all kinds of great stuff happening, and sometimes scary stuff. But getting back to some great stuff, I think this would be a wonderful lead-in for your history item, Maheen.
Okay, perfect. So for this week in space and astronomy history, I want to talk about Dr. Sally Ride, who became the first American woman to fly in space on June 18th, 1983. Her professional journey in general seemed very interesting to me, and so I'll talk a little bit about her and also a bit about the mission she was a part of. So, Dr. Sally Ride was initially a professional tennis player who was ranked 18th nationally. So, she was doing pretty good. And she even actually dropped out of college, where she was a physics major, to pursue tennis full time in 1968. And it was only 2 years later, in 1970, when she entered Stanford University, taking a double major in physics and English literature. And she had applied to NASA right after she had finished her doctorate in physics from Stanford, on seeing an announcement that NASA was looking for mission specialists. And on passing the preliminary process, she was flown to the Johnson Space Center in Houston for physical fitness tests, psychiatric evaluation, and personal interviews, which I was very intrigued hearing about that they also require a psychiatric evaluation. She joined NASA in 1978 and was one of the first six women to be selected as astronauts by NASA. And after 3 months, she was selected as one of the astronaut candidates, or as CANs for short. These are people who require 2 years of training before they become full astronauts. And this group was formed the same year she applied, which was in 1978, and was called the Astronaut Group 8. So she flew on Space Shuttle Challenger's STS-7 mission as a mission specialist on June 18th of 1983 and returned to Earth on June 24th. So it was like a week-long mission that she was on. There were multiple tasks of the mission, which included launching communication satellites for Canada and Indonesia. They also conducted the first successful satellite deployment and retrieval in space with the help of the shuttle's robotic arm, which was also operated by Dr. Sally Ride. And this was also not her only space flight. So she also traveled to space a second time, launched on another Challenger mission called the STS-41G on October 5th, 1984. So just a year after she first went to space. And this mission lasted 9 days, and was when she used the shuttle's robotic arm to remove ice from the shuttle's exterior and readjust the radar antenna. After leaving NASA, she became a physics professor and launched a variety of business ventures to inspire the next generation of astronauts and scientists. So I found her journey pretty interesting because it seems that it was very diverse. Even in the same field of physics, she went from doing a degree in physics to becoming an astronaut with NASA. And then after her time at NASA, she became a physics professor, which I believe after doctorate must have taken her a while to get to that point. And then she also launched business ventures, which were science related and for science promotion. So it just shows like a good glimpse of all the possibilities that are within physics in general.
Yeah, absolutely. It's one of these just incredibly accomplished people, but also it just goes to show it's like there are infinite possibilities out there. There's just so many things you can do with a physics degree, or in that case, she actually did take a major break as well, which I thought was pretty cool, dropping out of college to pursue tennis full time and then coming back successfully. So, I know a lot of times folks wonder or worry about taking breaks, but hey, if it's right for you, go for it. And wonderful and accomplished person, as you say.
Yeah, I wonder her in her journey, with being a professor, because I believe like after PhD, you have to do a lot of other things like postdocs and things to then become a professor. So like after being at NASA, a lot of people would just retire and not think about becoming a professor. But it was interesting that she still considered that and then put in all of that effort to go towards that path.
Yeah, yeah, exactly. Well, I can say it's you need to be a bit motivated if you want to take that on. And I will also say that little special shout out, as you mentioned the robot arm that she used. If we want to do our 2 degrees of separation from Canada to space, that robot arm was, of course, Canada Arm or Canada Arm 1, that she was able to use there. And sorry, S, I was going to say STSS, but it's STS 72, which is not a tongue twister, but it is for me for some reason. But yeah, the Canada arm has continued to be um, a majorly important part of International Space Station and space exploration, but it's also such a huge part of our space history. It's crazy to think this was all the way back on we were all the way back on Canadarm1 when this was happening. Um, Anyways, very fun stuff. And I saw your article and I couldn't resist putting another one in on the same genre. So I'm going to go ahead and hop over to a little bit farther back in time. So you were in the 80s. I'm going to go back into 1963 for my next this week's space and astronomy history. So June 16th, 1963. We had another actually very big first for women in space. This was Valentina Tereshkova, the first woman in space, 1963, 16th of June. So she was the first woman in space, and she also had a lot of firsts and was also incredibly accomplished. And it's got actually some interesting tie-ins because not only was she the first woman in space, she had flown solo on a solo mission on Vostok 6. And even today, I believe as I looked her up earlier, she is actually still around. She's 87, has had a very successful life by all accounts, and she's the last surviving Vostok program cosmonaut. And of course, back in 1963, when this was happening, um, were having delays. They had the Mir space station, not the ISS at that time, so they were looking at the Mir program, and there were a lot of delays happening. So they launched a backup vehicle that would serve as a sort of a temporary space station, and this was called Salyut 7. And on Salyut 7 was, of course, last inhabited in 1986, so it did last for a while. um, and they actually were taking equipment from Salyut 7 to the Mir space station when it was built, and so it was part of this very adventurous time. Now, Valentina Tereshkova, she not only was she up there, she orbited the Earth 48 times, spent almost 3 days in space, and of course, having been on a solo mission, she had all kinds of amazing firsts. She was also the youngest woman to fly into space until 2023, which is checking my watch last year. Um, so that last year, her age just got beat by the space tourist who flew on Galactic 02, which was the Spaceship Two Unity flight on the 10th of August 2023. That was a commercial flight, and so they had a space tourist who was younger. But she remains the youngest woman to fly in Earth orbit, and she had um, a huge career in all kinds of things. She was a skydiver. She was part of the Air Force and the cosmonaut force, and she basically went in as one of the first group of female cosmonauts in 1969 and remained in the space program. And she actually requalified for space, but she never went to space again. She retired from the Air Force at the rank of Major General. So she also went to a very high-ranking place, I suppose, after her space adventures. And it's interesting that this combination, the mission that she was on, going up to Salyut 7 by itself was a little space station in low Earth orbit. And it was there as a temporary sort of station. It was just a little, just had a few little modules. It was meant to patch the time between, until they could get Mir up and running. And Salyut 7 had a lot of problems. It was in the air for 8 years, or in orbit for 8 years and 10 months. And of course, being visited by Valentina Tereshkova on her flight. Salyut 7 had, several missions, 6 different crews went up, and a lot of technical problems. It had leaks, it had fuel leaks, it had a lot of repairs, and they had multiple different repair missions to go out and try to fix different leaks. But finally, they actually lost contact with the space station. And this is where the conversation goes back to space junk, because when they lost contact with the space station in 1985, so 20 years still, they lost contact, the station began to drift. It made unpredictable movements in orbit, and the systems on the Salyut 7 shut down. And in the late 1980s and early 1990s, for those of you paying attention to the solar cycle, the sun's activity kicked up, and high solar activity increased the atmospheric drag on the station and actually pushed it in basically into the atmosphere, sped up its orbital decay, and this entire Vostok 6 thing went uncontrolled re-entry. That's right, giant piece of space stuff on an uncontrolled reentry, 7th of February, 1991. Very terrifying. So this is exactly what you don't want to have happen with your space junk, and especially not really, really massive things like the entire Salyut 7. It's with its docking trusses and its panels and its fairly large size. So it was long and wide. So it has 16 meters by 4 meters, I think, 5 meters, something like that. Um, so it had a pretty big heft to it. And I don't know exactly how much it weighed, but when it came down, they were really, really worried. It actually had an uncontrolled reentry over the town of Capitan Bermudez in Argentina, and it overshot its intended reentry point, totally uncontrolled, speeding out of control through the atmosphere, likely in a ball of fire. And it basically, fortunately, went over the ocean, and so it went into an uninhabited portion of the southern Pacific Ocean and splashed down somewhere, probably in pieces. Huge, giant space junk problem. So it ended up being, uh, I don't know, this week's space astronomy history, very interesting times. So thank goodness it landed on an uninhabited portion, because these things come down at critical velocity, terminal velocity.
I'm really glad nobody got hurt and we were lucky enough for it to land in an inhabited area. But, speaking of space junk, to think that, we've had this space junk problem since such a long time is pretty concerning. Um,
Yeah, yeah, exactly. Totally. It's been an issue. We've known it's a problem, as I say, since the 70s. People have been writing papers about this, and space debris are considered anything that's up there in low Earth orbit that is defunct, no longer controllable, derelict. You've got abandoned launch stage vehicles up there. You've got mission related things, fragments. There's even solidified liquids from fuels and things like that, unburned particles from solid rocket motors, paint flecks, actually, pieces of paint. All of these space debris are up there, and we haven't even started being able to track them all because, of course, they're un um, they don't have any movement of their own. They're just orbiting around randomly, waiting to collide into something. So uh, you know, they're still trying to track them, and I believe as of sort of last count, they're running over 30,000 artificial objects in orbit above the Earth. Now, some of those are operational satellites, and 6,000 of them are SpaceX operational satellites. But collisions have been massive, and there have been quite a few close calls. So both the US and Russia alternatively at various times blew up satellites in orbit and caused debris clouds. Um, so we should know better by now for sure.
Yeah, it seems
um,
like space tourism might just become about looking at debris at some point with how much we have in that area at this
or
point.
yeah, or dodging the debris. Because I mean, if you're a space tourist now, the one thing you don't want is to hit any of that stuff. It does seem that a lot of it is in low Earth orbit. So one thing people are saying is, okay, well, what if we put more in higher orbits? But then you're just going to have the same problem at higher orbits that we have at lower orbits. It is, and the orbits are affected by, of course, Earth's gravity, and Earth's gravitational field has small variations due to the density of our planet. Um, so it's, and of course the moon going around and all kinds of things. So we can have, satellites get knocked out of orbit, and if the sun is active, like it is right now, it gets even more interesting.
Yeah, I'm glad we have limitations because I'm sure if we did not, we would have space debris much farther back from where we're seeing it now.
Yeah, absolutely. Now, speaking of, I suppose, going out and hopefully not getting any collisions. Yeah, if you are going to have humans in space, you definitely don't want to collide with any of that stuff. So that can get us to your next item, Maheen.
Yeah, that's a great transition. So my next item for this week is the first private manned space flight launch on June 21st, 2004. So this was a major turning point for private space flight when Spaceship One, which was the first non-governmental crewed spacecraft, flew 100 kilometers above Earth's surface. In terms of how far it went, it crossed the Karaman line. Hopefully, I'm pronouncing that correctly, which is defined as the accepted point of entry into space by the International Astronautical Federation. So, Spaceship One was designed and fabricated by a company called Space Composites, owned by aerospace designer Burt Rutan. Its development was also backed by Microsoft co-founder Paul Allen in a joint venture known as the Tier 1, with an objective to develop low-cost routine access to space, which I personally find to be a questionable idea, particularly the routine access part. The spacecraft was 28 feet long, and its cigar-shaped fuselage, which is the main body of an aircraft, was about 5 feet in diameter, allowing to carry a pilot and up to two passengers. It was launched in mid-air at an altitude of about 50,000 feet from undersight of White Knight, which was a turbofan-powered airplane, and the spacecraft's mothership. So essentially, it was able to reach just beyond the atmosphere with the help of its rocket motors, which fired for about 80 seconds to provide enough push from the mothership. So this was a suborbital flight, which means that the Space One ship arced through space for about 3 minutes and then glided back to Earth without making a complete orbit around Earth. This particular ship made two more flights before it retired from active service. Now, the more interesting part of the story is the origin of the Spaceship Two, because it's more recent, and its carrier plane White Knight 2 in 2009, which was only 5 years after the success of Spaceship One. This specific venture was provided backing by entrepreneur Richard Branson and his commercial space flight company Virgin Galactic, which I'm sure a lot of people have heard of at this point. And in contrast to Spaceship One, which could only fly two passengers with the pilot, Spaceship Two was designed to allow for 6 passengers. So the idea of it is to allow for suborbital flight about 100 kilometers above Earth, offering a few minutes of weightlessness, and then return to a runway landing. And the purpose of all of this is, of course, space tourism. And currently, based on my research, the flights cost between $250,000 to $450,000, which sounds very affordable. And although customers were initially promised to be flown into space by 2007, the development of this process at the time was still in process, and they couldn't actually fly at that time. However, there have been more recent commercial space flights that have taken place over the past 2 years, with one worth mentioning, or the most recent, is the launch of Galactic 6, which was the sixth commercial space flight in January of actually this year, and it carried 4 private passengers. Now, based on my research, most of the passengers that have actually gone on these missions so far have been either trained astronauts or people familiar with flying in some area. But a lot of the information regarding who flew is also private, so we don't really completely know if it's just random people who have had no experience with flying before. But that would be something interesting to know as well.
Yeah, of course, and it is very exciting, as you say. It's a really interesting history because back in 2004, this was really, really new. And in 2004, no one else was anywhere near Spaceship One. And I'm old enough, I remember how exciting it was when we got the first flight and the first schematics from Space Composites were actually put out there. And the designs they came out with were so different from anything anyone had seen before. It doesn't look like a rocket. It's sort of like a really cool airplane thing. Um, and that was 2004, but the implementation was so much harder than they thought to get it to the safety level because these guys didn't want just space tourism. They wanted, as you said, they wanted to make space flight or getting into low Earth orbit actually easy. Something that anyone could do. Anyone who could walk onto an airplane could get into this spaceship. But the problem was that to make it that safe and to make it that feasible was way harder than they thought. And they had a lot of safety issues, which is why they did not beat SpaceX. And right now, everyone's like, oh, yeah, SpaceX is doing all this stuff on Blue Origin. And we don't hear as much about Virgin Galactic because, they're slowly but surely moving forward. But it's taken them a really, really long time. And it is interesting that, of course, Blue Origin, they um, they were able to send up, William Shatner, who I think is 90 years old now, famous Canadian, but definitely not an astronaut, definitely not trained in anything. Um, but Virgin Galactic, I don't know. As you say, we don't know a lot about their passengers. Maybe they just have better privacy information. But having flights that are easy and presumably costs that come down, it could actually make them a real commercial contender if they can catch up to things like SpaceX, in terms of their capacity and their frequency of flying. So, for better or worse, space flight is something we have to keep considering. Although,
Yeah,
if we get more junk up there, it might not be so fun anymore.
yeah, it definitely brings your hope high, to be able to actually go into space. And it's actually quite affordable. It's only equal to my undergraduate degree. But on a more other serious note, I'm really curious as to why they would think it would be useful to have people have the ability to have normal access to space, like a routine access to space. How would that help anyone?
It's actually there's a couple really fun practical uses. One is that if you use these spacecraft and you do go into orbit, you can get from pretty much any 2 points on the planet. Um, you can go up and come down, and I think it was about 2 hours, maybe three. But that means you could have travel from anywhere to anywhere in about 3 hours. So I could go to Australia in 3 hours instead of it taking me 26 hours like it did last time.
But what if like a lot of people start doing that? Then wouldn't that cause issues if like so many spacecrafts are doing that?
Well, we have to then consider what kind of fuel the spacecraft are using, because of course one of the big problems with regular airline flights is the that they are really tremendously polluting. um, they're very, very, very bad. So using an airline flight is bad, very incredibly bad for global warming and the environment. If we start doing this more, we'll have to consider what that impact is. But other than that, you'd have to have a flight pass, so you wouldn't collide with other travelers. And if you were doing this regularly, it'd be a lot easier to put things into low Earth orbit, make an expanded space station. There are people who want to put a space hotel up there, but there's a lot of research in astronomy that you can only do outside of the Earth's atmosphere. So it would make a lot of instruments very, very easy to place outside of Earth's atmosphere, or even potentially take to the moon if we ever get that lunar gateway working. Um, so I think I can see why people get very excited about it, but I have to say I would want to wait until the safety requirements got a little bit better.
No, I totally agree. I think we could also potentially run into a lot of problems, which we would only realize after we went that far. But yeah, it's still those are some great points to look into.
Yeah, and I mean, people spending a long time in space or even on a lunar colony, we already know that there's going to be permanent physical effects to your body if you do that. So there's definitely more information needed, and it is not particularly close to being ready, as far as I can tell. Is a
Hmm.
250 to, I mean, even if they half the price, that's still $125,000. That's that's a lot. I mean, millionaires can buy
Yeah.
tickets, I'm sure, but um, I need that to go down by several zeros before I start thinking about it. But in any case, I almost forgot to do the reminder. So this is actually just our little sparkler reminder, folks. You are listening to York Universe, broadcasting live from the Allan Carswell Observatory. Right now, the OPV crew is showing beautiful live images of the lunar surface. That's right, the lunar surface where these space missions might take you someday, to go visit a lunar colony, get moon dust in your shoes. And we are, of course, at York University in Toronto, Ontario, Canada, broadcasting live from the Allan Carswell Observatory. And if you want to find out more about this show, our notes, or of course any of our previous episodes, you can go to yorku.ca/science/observatory. You are currently listening to Maheen and Elena, and right now we're talking about space junk and satellites and history. It is pretty fun. Oh, and I just found out that actually that image of the moon that's on OPV right now is the Apollo 11 landing site. So if you are listening to this later on in the archive, make sure to go look up those moon images on our online public viewing on YouTube. All right. Thanks everyone for bearing with me with my slightly late middle announcement, we do have one or two tiny reminders. First reminder is that, of course, we have the Astronomer in Residence program kicking up again at Allan Carswell Observatory. And that means, of course, if you want to follow along with our Astronomer Residence blog, that's also on our website, yorq.ca/science/observatory. The Bortle class Dark Sky Preserve Killarney Park has astronomers going out all summer well, hosted by us, and we are operating the observatory out there to bring you even more wonderful images and astronomy programming. So go ahead and check out the OIR blog. Our next astronomer is Veronica Dornan. And this week, we will also be having a June 19th atrium tour, if that wasn't enough, on the Wednesday per usual around 9 o'clock p.m. Obviously, it's still just a little bit bright at 9 o'clock because it's the middle of summer, but if you want to catch those atrium tour tickets, they're also on the website. All right, let's get into some news items. There are, as you say, so many things going on. And of course, we couldn't help but teaser some of them a little bit. What do you think, Maheen? Shall we talk about the space junk first, or do you want to go into something a little more exotic?
Up to you. I'm okay with either.
All right, let's do the space junk first because this hasn't been in the news all week, and we've been talking about space junk and, of course, the Kessler problem. We've been talking about, entire modules coming down, and now we have more space junk than we have ever space junked before. We have an orders of magnitude more space junk, and a lot of it is Starlink. Every time solar flares get active, the sun gets active, a few Starlink satellites come down, and SpaceX space junk has reached apparently reasonably critical mass, a huge chunk of it, several pieces, I think 6 to 8 pieces of very, very large, over 100-pound chunks of metal came down earlier this week, or last week, it's Monday, last week in Canada, in Saskatchewan. So near Ituna, Saskatchewan, a whole bunch of space junk actually landed, hit Earth on property where humans live, and 8 pieces were found on 5 different farms in Saskatchewan, all within a 30-mile radius. There might have been more out there, but it was all from SpaceX, and this is a problem. The space junk on one farm alone was over 246 pounds of space junk. This is going, terminal velocity, at least when it comes in. And they're saying, of course, SpaceX says, oh, we think that the space junk will burn up. But these were way, way, way too large pieces to burn up. This in particular was thought to be part of what's called the trunk of the SpaceX Dragon capsule, launched back on February 9th of 2024. The SpaceX Dragon capsule did come back successfully where it was supposed to in a controlled landing on February 26th. But SpaceX, this trunk it's huge. Look at the pieces online. They're giant. Fortunately, this farm was not incredibly densely populated, and it landed where the humans weren't. But it could have very easily landed on, something a little bit more spicy. So it's really, 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 really lucky that this many large 100-pound chunks came down at that speed and didn't hit anyone. SpaceX has over 6,000, as mentioned before, over 6,000. They're planning to go to 20 or 30,000 Starlink satellites. They claim that those satellites will burn up completely when they re-enter. But if they're at full capacity, we might see up to 23 reentries per day. And if those reentries are all making it to the ground, dropping hundreds of pounds of garbage, eventually it's going to hit somewhere where there are people. And that's going to be a real problem because this is going extremely fast. If it had hit a house or a car, it easily could have actually caused a fatality. So it is actually very, very important that we continue to advocate for, I don't know, laws and regulations on this stuff. And the satellite pieces, or I should say the trunk pieces from the satellite launch that came down, they were actually collected by SpaceX. And if you haven't seen it, what they did is apparently they sent two very like shy fellows in a little tiny U-Haul, and they drove up to these farms in Saskatchewan and made some sort of donation to the local ice rink. So, very spicy, happened just last week and really illustrates our point that yes, this is a serious problem and we should absolutely be asking for the people behind these satellites to have um, some responsibility where the large pieces do not come down on humans. That would be very bad.
Yeah, I saw the pictures and it does not seem like it was close to burning up. Like they're really big pieces. And with
Yeah.
the 23 entries per day, I'm pretty sure the re-entry and falling on Earth poses a more serious threat. But I'm thinking, does burning up of these falling pieces, does it pose environmental threat? Does it affect our atmosphere?
Yeah, it actually does put metals into the atmosphere, and the amount depends on how much, right? So if we're going to have a lot of these things partially burning up, it's going to cause all kinds of different effects. And yeah, you're absolutely right. These are huge, giant pieces. I mean, these are no comet dust grains will burn up in the atmosphere. These are huge, huge pieces of space junk that will not burn up, and they are burning up. They're putting material into the atmosphere. They're causing hazard, and it's a real safety risk. So
Yeah, it just takes us back to our point of, going on to the more of the root of the issue and getting rid of space junk than to relying on it burning up before it falls on Earth.
yeah, and you should. I mean, I'm a big one. A big fan of just putting in like, hey, if you put it up there, you're responsible for getting it down safely.
Mhm.
Um, in any case, we have a few more minutes for some fun news items, so this might be the perfect time to go and talk about something a little bit different.
Okay, so I'm gonna share a space news, which is completely different in direction from what we've been talking about so far. So it's a great way to end off on a different note. So, this recent news is about exotic black holes, which might be a byproduct of dark matter. So, for those of you who might not know, for every kilogram of visible matter, there are 5 kilograms of dark matter in the universe, which is an invisible entity only detectable by its gravitational effects. So, we do not have a direct way of observing dark matter. And 50 years ago, physicist Stephen Hawking proposed that dark matter could be primordial black holes, which were formed shortly after the Big Bang. MIT physicists have now found that these early black holes might have produced even smaller black holes with a unique property called color charge. These tiny supercharged black holes likely evaporated quickly, but could have influenced the formation of the first atomic nuclei. In terms of the color, what color charge means, it is basically a property of these elementary particles known as quarks and gluons that is related to the particles' strong interactions in the theory of quantum chromodynamics. And I think it'll make more sense as I talk a bit more about how it's related to this black hole formation. David Kaiser, who is an MIT professor of physics, explains that these short-lived black holes might have affected cosmic history in subtle ways which are detectable today. So Kaiser and graduate student Alba Alonso Monsalve's study, published in Physical Review Letters, explored the formation and composition of primordial black holes. And what they found was on calculating that these black holes, they found that these were formed within the first, bear with me on this, quintillionth of a second, which is about 10 to the power minus 18 of a second. So extremely small time span after the Big Bang. Quantum chromodynamics theory, or QCD, suggests that early universe was a hot plasma of quarks and gluons, going back to what we talked about, the color charge, and any black holes formed then would have absorbed these particles and their color charge. So the smallest black holes containing maximum color charge would have disrupted the early universe's equilibrium. So if the equilibrium is disturbed, it could potentially influence the formation of atomic nuclei, uh, leading into, the existence of these primordial black holes. Alonso Monsalves also suggests that these primordial black holes could have left observational imprints, changing the balance of elements and potentially providing clues to the nature of dark matter. This study opens new possibilities for understanding the early universe and dark matter. And it also makes me think of, another big mystery of origin of supermassive black holes that we see today and how they're so big today. This could also potentially help us in understanding that part of the mystery with the black holes if they were produced in the primordial times, such a small time after the Big Bang, from dark matter.
Yeah, this is super, super fun, and I'm glad we got to cover it, even though it's very different than what we were talking about before. Of course, Stephen Hawking could have been right because it's also, remember, he's also the one who proposed Hawking radiation,
Mhm.
which is how black holes could evaporate. And for all but the very, very smallest black holes, this would happen very, very slowly. But at some point, you do get black holes small enough that they can evaporate. But in the early universe, you'd still have them. And so this leads up to all kinds of interesting questions about early universe dark matter, right? And whether or not these, as you say, these short-lived black holes might have affected cosmic history. If you had, if this was the answer, then your black holes would have the choice of either evaporating or getting bigger. And we do see big black holes today. So it is very, very very tempting. And of course, one that I realize we should probably have people pull out their rubber sheets to do the gravity bending on.
Yeah, I
Uh,
definitely feel like the concept of evaporating black holes is just a very interesting concept and hard to really imagine as well when you really think about it.
yeah, well, I mean, this is why Hawking radiation is such a was such a breakthrough. And on the edge of a black hole, that you could have something emitted, and the black hole would lose a small amount of its energy when particles escape over time. So an evaporating black hole would have a finite lifespan. But I mean, most black holes are so big that any black hole formed in the early universe um, would still be around. But they've done the calculation and showed that if you had a mass of less than 10 to the 12 kilograms for your early black hole, which would be a pretty small black hole. I don't know how big the event horizon would be on that, but it'd be really small. But that would have evaporated by today. Um, so if you saw more dark matter that could be attributed to that in the earlier universe than you did today, there would be something to say there. Quite fun. And of course, there's observational tests that we can do for that, which I love. So
Yes,
let's get out your telescopes, everyone. Let's go galaxy observing.
I totally support that.
All right. Well, on that note, we've still got lovely images of the moon happening, but we do have to round up the show. So we're going to go ahead and say thanks, everyone. It's been a wonderful Monday and a great show. Lots of fun chatting. And of course, we had Maheen on for the very first time, which has been super fun. You have all been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Maheen Hamani and myself, Dr. Elena Hyde. And of course, you can always connect with us on Instagram at Yorkie Observatory, Facebook at Allan Carswell Obs, and check out our website for show notes, content, updates, and the archive at yorku.ca/science/observatory. Thanks for tuning in to York Universe, everyone. Clear skies and have a good night.
Have a good night.